So this last part of section 3.1, we're going to revisit the idea of finding exact values for trig functions. Now recall, we were able to do that for things with 30, 45, 60 in our quadrantal angles, right? So those were things that we were able to do. We built ourselves a nice representative right triangle, used our ratio, and we kind of went along. So we can basically redo that. I'm going to stay in radian mode and answer the question in radian mode, but you are more than welcome, as you kind of get used to this, right, is to go ahead and convert pi over 6, convert 3 pi over 4, etc., convert them to degree mode, use what we learned, right, with regard to reference angles and whatnot in that mode, and then walk it back into here. So you know, be my guest if you want to do that. But again, since we're in radian mode, I'm going to stick all the way. What I'm also going to do is kind of use this handy dandy little reference sheet. All right. We found what the corresponding things are in each quadrant, and then we can kind of get a feel for the reference angle in each part. So that I'll have off to the side here to kind of help myself out, since we are just kind of making that adjustment. Again, I'm hoping that we'll do this so much that a lot of these numbers will be just kind of fresh in your head. When you move forward, it'll be automatic. But this is new, so let's have our little cheat sheet off to the side. So sine of pi over 6, right? Well, pi over 6, right, that is basically a quad 1 angle. All right, and the pi over 6 is basically its own reference. So it's a 30-degree reference if you wanted to kind of go there. And so for in this guy right here, if I have a 30-degree reference, right, what I end up having was square root of 3, 1, and 2 as my sides. So sine being opposite over hypotenuse, I expect an exact value of 1/2 for that situation. So again, I'm recognizing which quadrant am I in. I'm recognizing the reference angle that I have. I went ahead and snuck into degree mode there, drew it, and then drew my representative right triangle, and then I'm basically using my hypotenuse and adjacent and opposite for my definition. So what about 3 pi over 4? Well, again, looking at my cheat sheet, 3 pi over 4 represents 135 degrees. So this is sitting in quad number 2. It's got a 45-degree reference. So if I draw my little picture, right, this little picture would look like that, right, with pi over 4 there. This would be -1, this would be +1, and that would be square roots of 2. So cosine is the adjacent over the hypotenuse. So we're going to get -1 over the square root of 2. Rationalizing my denominator, we get negative square roots of 2 over 2. So there's my exact value of essentially 135 degrees, right? That's basically what it is. What we found, I think it was section 2.1, 2.2, somewhere back there. The next one, tangent of pi over 3. Well, pi over 3, right? That corresponds to a 60-degree reference in quad number 1. So if I drew a picture of this situation, right? There's my 60-degree angle. We have square root of 3, 2, and 1. So the tangent is the opposite over the adjacent. So this would be the square root of 3 over 1, which we know to be the square root of 3. So I'm really mixing that dance of what we know from degree mode and quadrant mode to help me out in this radian mode, since we're so close to that switch, and hopefully this handy dandy cheat sheet's helping us out. So trying to make things harder, what's the cosecant of 5 pi over 4? Well, again, the 4 tells me I'm expecting a 45-degree reference, right? 5 pi over 4, that's just a hair over 1, so I'm expecting this to be in quad 3. Of course, to verify that in my cheat sheet, right, there's 5 pi over 4 occurring as a 225-degree angle with a 45-degree reference in quad 3. So what does my picture look like in quad 3? There's my pi over 4 reference angle. That's -1, that's -1, and that's 2. So cosecant, right, that's basically my hypotenuse over my opposite. So for this picture, my hypotenuse is, oops, that should be a square root of 2, you guys. That is square root of 2, and my opposite is -1. So we get negative square roots of 2 for our cosecant of 5 pi over 4. So again, I'm kind of grounding it in degree mode as we make that transition into radian mode. 4 pi over 3, well, that 3 tells us we have a 60-degree reference. Again, 4 and 3 is pretty close to 1. So again, I'm imagining we're in quad 3. Looking at my little cheat sheet over here, there's 4 pi over 3, corresponds to 240 with a nice 60-degree reference. So if I drew my corresponding right triangle, right, we have a reference angle of pi over 3 or 60 degrees. This would be negative square roots of 3. This would be negative 1, and that would be 2. So secant, right, is my hypotenuse over my adjacent. So for this picture, my hypotenuse is 2, and my adjacent is negative 1. So we're getting a negative 2, right, as our value there for the secant of 4 pi over 3. So again, just weaving that story between our old idea of degree mode, reference angles, corresponding right triangles, and where I'm at in radian mode. Last but not least, 11 pi over 6. Well, that's 6. Tells us we have a 30-degree reference. 11 divided by 6, well, that's close to 12 divided by 6, so this is really close to 2. So that tells me we are in quad number 4, because I try to write 4. And again, you can see, yep, I am right. 11 pi over 6 is a 330-degree angle with a 30-degree reference. So what does my picture look like? Well, we have a 30-degree reference, or basically pi over 6 reference. That would be the square root of 3. That would be negative 1. And that would be 2. So my cotangent, by definition, is my adjacent over my opposite. In this picture, my adjacent is the square root of 3. My opposite is negative 1, giving us a value of negative square roots of 3 for that picture. Okay, so there you guys have it. Mixing in, I think there's so much more we can do, but so far, right, in 3.1, now that we've transitioned over to radian mode, we can basically revisit the idea of coterminality in radian mode. We can revisit the idea of reference in radian mode, and then we can find exact values of trig functions as long as we have a 30 degree, which is pi over 6, 45 degree, oops, forgot my degree symbol, which is pi over 4, right, or a 60 degree, which is pi over 3. So pi over 6, pi over 2, and pi over 3 reference angles respectively for each. Alrighty, so there you guys have it. That wraps up section 3.1. So much more to the story as we move deeper into chapter 3. And I will see you guys then. As usual, if you have questions, you better ask. Ask them on Canvas. Send me an email. Visit me for an office hour. Whatever it takes to try to help this transition happen. Talk to you guys later.